Okay, so chapter 3 now talks about the protocols and models governing our network. So, topics that we will be discussing here is on the rules, the protocols, the protocol suites, the standard organizations, and the reference models, data encapsulation, and the data access, or how do we access, or how does our local host access our local resources on a network. So, when you say rules, so rules talks about the how does your what should be done and what should not be done, diba? Or you need to do have those access, or if you could have those access. So the rules now have this three in our network. We have these three rules or three elements for our communications. So you cannot communicate now if there would be no sender. So there should be a source or the sender, the destination or the receiver, and the channel or the media. So this media no provides those for the path of the communications to occur. So our networks can vary in different in their size, complexity, and it if it has enough connection to have a connection. So devices should agree on how to communicate. So when you have this communication protocols, here are our three communication protocols. No, all communications are governed by protocols, and this, for example, so if we send a message, no, there would be a messenger. So you as a sender are the one who is called as a message source, and then the signal is the one that transmit that message and through a particular transmission medium. It can be either via cable or via Bluetooth or Wi-Fi. And then the signal, then after that, the receiver will then uh, receive the message, and then or have or asa siya dapit padulong, no, and then after that that message will be then um, the madawat or maabot dito sa message destination. So that is how your communication protocols works. Same goes with when you communicate, no, a computer. So na siya computer. So this is the message. So the message is sent through a particular transmitter or a particular transmission medium. And then after that, that particular message will be then received by the receiver to that particular destination or that particular message destination. So meaning na siya ay dapat sender, receiver, and the media or the channel. So in the rules establishment also, individuals must use established rules or agreements to govern the conversation. And also this for the first message is difficult to read because it is not formatted properly. If I try to read onto this, for example, the humans communication between governed roles, it is very difficult to understand messages that are not correctly formatted and do not follow the established groups and protocols. A structura da grammatica di lingua, di ba? If you read onto that, the first message is difficult to read because if you have observed, there was no capital letters or for the first messages since it was not properly formatted. While the second message, Ganesha, if you try to read onto that, it shows the the message is formally or properly formatted. And then also, no, protocols must account for the following requirements. It needs to identify the sender and the receiver, and there should be a common language or grammar. Let's say, for example, when you communicate with a particular person, ikaw that particular person is a American, and then you as a Filipino, and then oh, 'di ba? What does Filipino do for you to communicate with other with that American person, 'di ba? You change your grammar, you change your I mean you change your language. So you change your language into English if you know English. Pero kung ang imong kastorya is in Spanish and you're not fluent or you don't understand Spanish, there would be a hard communication between the two of you. So that is how the rules of establishment works. And also the speed for the network, no, you need to also to have the speed and timing of delivery, the confirmation and acknowledgement of requirements. So in the protocol requirements and the network protocol requirements, the common protocol, the common computer protocols must be in agreement, which include these requirements. There should be a message encoding, the formatting and encapsulation, the size of the message, the timing, and the delivery option. So when you say message encoding, so since when you from the word itself encode, so it is somehow you convert those information into an acceptable form for transmission. Let's say, for example, this one here, kini, the message is then is sent via signal, and then si encoder is yan ang gina-convert. So, yan ang gina-encode, then i-transmit, and then i-agi niya sa channel, then the receiver, and then after that, si signal dayon is iyan ang i-decode. Since, let's say, for example, maingon tao, mura ni siya og ginatawag nga translator. So, na siya yung message encoding, gina-translate niya so that the computer then understands what are you trying to send. So, since our computer only understands ones and zeros, bits, I mean, so inana siya ang kuan. So there is a so after the encoding there should be also a decoding, meaning yamang gi-decode, gi-transform or convert ng information. So after that pag abot dito sa destination dire, so there should be a in decoding, I mean. So to interpret the information sent. And next is the message formatting and encapsulation. So message formatting and encapsulation, no? So when you send a message and format when a message is sent, no, it must use a specific format and structure. Let's say for example, when you send a message sa post office, 'di ba? Unsay dapat naa sa upper left ang sender, nasa upper right ay lower left, upper left si sender, and then sa lower right si receiver, and then sa upper right man kay ang naatoy stamp. So, and then inside of that message, inside of that envelope is naka-encapsulate dito ang message. So, meaning the encapsulation is done by the envelope. So, more inana siya sa una ang ato ang message formatting and encapsulation. But karon no, we have this also, the kini. So, kini siya karon is we tend to depend our format depends on the type of message and the channel it is to deliver. So for example, you are traveling in an IPv6 and naapod siya different bahin-bahin unsaon siya pagka format and pag-encapsulate sa imuhang message. So but then all of it has its uh, should have those source IP address and the destination IP address. So always dapat naa siya destination and source address. So the message siya is also no in the encoding between hosts must be in a appropriate format for the medium. Why? It's because messages that are sent across the network are converted into bits, and these bits are either patterned into different media or medium. It can be either via fiber, katong light, sa sound, depende po, or electrical impulses. So, depende na siya. And so, the destination must encode those signals to interpret the message that has been sent. Okay? So, next is the message timing. Another is the message timing. So, is the message timing that includes the following: the flow control, the response timeout, and the access methods. So, when you say flow control, no, it is the rate of data transmission, and so it's somehow from the word it's a flow. So unsa ang speed on the data it has been delivered, and the response timeout is, 'di ba, it is how long the data the device waits when it does not hear a reply from the destination, 'di ba? If you try, for example, if you try to ping Example lang, hinay ka mo internet, what did you do, di ba? You try to ping on the google.com, ana, or fat, ana. Pagka man dayon kasi may tabo. Kung dugay siya reply, mayon na siya request time out. Or somehow mo na siyang usahay mo kung sa web page sa niagi mo na siyang this site can't be reached, so meaning there is a response, there's a delay or there's a waiting time nga maka-reply siya. And then you also have this access method. It determines when someone can send a message, so somehow this will check or determine no if that particular person or particular device can access or send a message to that particular person, para good nag sa messenger nga imong gina-block. So you have those access methods. So we also have this delivery options. So sa delivery options, no, it can be either by three. So we have these three methods. It can be either unicast, multicast, or the broadcast. So when you say unicast, it's a one-to-one communication. One-to-one meaning one source to one destination. Meaning isa lang kabuk ang imuhang tuyo. And then the multicast, it is a one-to-many. And typically not all. So meaning it's just a chosen one. So, mga chosen lang to nimo ang multicast. Well, the broadcast means you send the message to all. Like for example, kana bitong sa NTC, 'di ba? Somehow kung naay mga linog-linog, they send a message to all of their subscribers or to all of those subscribers of that particular kanang kanang nga network para maka-receive sa alerts. So inana siya si broadcast. While si multicast is like mura siya GC. So di ba kung mag-GC mo is pinili lang nimo kung kinsay maka-receive, which is kamo yung join sa GC. While the unicast is katong PM, personal message, is aragid kabuo. Okay, so that is the difference of those three. So inane po siya no when you try to look it in via node. So we also have this mga network protocol overview. So naatay defines a common set of rules, no? Can be either by a software, it can be implemented sa software, sa hardware, or pwede po both. So and also those protocols are um, have their own function, format, and rules. So it can be either ang imong protocol type is can be either it's up for the network communications or kung pwede ba maka-communicate ang one device to the other or duha ka device or to more device and all. Then the network security. So the network security now it's somehow a protocol type that you need to secure those data to provide authentication. And then the routing no is these are somehow enabled in the routers. If they could exchange route information and compare their path information, and also the service discovery, it is just used for automatic detection of devices or services. And then the network protocol functions now allows us or this the devices use agreed upon protocols to communicate. So protocols may have one or functions. So na siya yung mga inana. So na siya yung mga different function, addressing, reliability, the flow control, sequencing, and the error detection. And last is the application interface. So na siya yung mga different network protocol functions. And another one is the protocol interaction. So we also have this four protocol interaction. Networks require the use of several protocols. So each of these protocols has its own function and format. So for example, these are the most common for protocol, no? The HTTP, the TCP, and the IP, and the Ethernet. So see, when you say HTTP, there's are somehow like for example, mag-internet ay mag-access ka o kaning network, no? Or I mean network ay web page, di ba? Kasi may tabo HTTPS that, diba? HTTPS kato dayon www.facebook.com. So inana na siya. They are governed by the hypertext transfer protocol. And then also have this that TCP, the transmission control protocol, which somehow are governed in the individual conversation. So kana mga messengers na sila yung mga transmission control protocol. And then the internet protocol or the delivers messages globally from the sender to the receiver. So inana is kanang IP address mo na sila mga internet protocol na sila, the sender and the receiver. And then the Ethernet wherein it delivers messages from one network interface card to another on the same Ethernet um, local area network. So na yung mga inana. And then the protocol suits, no, this must be able to work with other protocols. So when you say protocol suite, it is a group of interrelated protocols. So daghan na sila. So sa physical layer lahi, sa lahi nga layer lahi po din niya sa layer. So na siya different protocols on each of these network ay on each of the layers. So we also have this evolution of protocol suites, the TCP/IP and also the OSI. So naatay since they are grouped accordingly, no? So when they are grouped accordingly, so naatay upat ka buok nga type. We have the TCP/IP and the OSI and then the AppleTalk and then Novel Netware. But we will be only talking with the TCP/IP and the OSI model. So when you say the TCP/IP, it has four protocols nga iyahang gi-govern. Ay four ka layer lang ang naay iyahang naa sa iya for the TCP/IP model. So it has the application layer, the transport, and the internet layer. Then we also have this network access layer. So these are those mga layer ay protocols governed by these each of these layer. So sa TCP/IP protocol example, now we have this we operate this at the application transport and internet layers. And the most common network access layer or the local area network no protocols are the Ethernet and the WLAN or the wireless local area network. In the TCP/IP protocol suite or sa iyato nga model, since naman siya upat no kani so mo po di sila. So later on, as you go along with your networking, my tabo is you will learn all of these layers or these protocols of each of these layers. So kanina, they connected oriented and the IPv6 and then the OSPF, EIGRP, ICMP. So kana sila ma-discuss na ni siya sa networking too. So how does the CPIP communication process? So a web server encapsulates a message and sending a message to a client. And since si client na yun is yan itong i-de-encapsulate the web page for the web browsers. Inana siya. So as we all know, we also always have since si internet no ha, is walay tag-iya. So there are organizations or standard organizations that um, governs our internet or mga devices of our network. So we have an open the IEE, IANA, IETF, ICANN, ETU, TIA, and some of those. So they encourage the interoperability of our network, competition, especially since naamang gimingon nga mas kusog si like for example sa to mas kusog si PLDT, mas kusog si Parasat, mas kusog si Converge. Actually, no, it's just that the problem with that is that pareha man na sila kakusog. It's just that daghan lang subscribers si PLDT o si Globe. And sige, di ba? If you look into it, ilang marketing is taas. So mo nagakay tabo. And also, no, standard organizations are always vendor neutral, meaning they don't have this kung asa sila dapit nga mga na kuan. And they are a non-profit organization and they established to develop and promote the concept of open standards. So we have this internet standards, the kinino, ani ISO, that it promotes the open development and evolution of internet, the IAB, the Internet Architecture Board, the IETF, wherein it develops and updates and maintains the internet, the CPIP technologies, and the IRTF, or the Internet Research Task Force, wherein it focuses more on the research related to the internet or the TCP/IP protocols. Si IANA po dayon, no? We also have the standard organizations involved with the development and support of the TCP/IP. So si ICANN and then si IANA. So si ICANN, no, these are somehow sila mo coordinate sa IP address allocation. So meaning si PLDT mo palit na siya dadto kang ICANN kay para maka-coordinate kay meaning kung ato diri sa Pilipinas 192 gid na siya ana 192 that's for the public IP addresses. And kung mingon kag adto ka sa Manila or I mean sa lahi nga nasod, they also have its own public IP address. And then we also have this ICANN or the Internet Assigned Net Numbers Authority, wherein it oversees and manages the IP address allocations, domain name management, and protocol identifiers for ICANN. So sila man to'y pamili, ilang gina-check, and all of that. We also have mga electronic and communication standards. Motong si IEE, si IA, si TIA, and the CTUT. 'Di ba? Sa inyohang Ethernet cable na atay unsa nang nakabutang diha, unsay naka-protocol diha sa inyong internet cable is the murag TIA ba to ITU at TEC. So under gyapon na sila diha sa TIA. So they are somehow those um sila po yung nag-govern sa mga standards of our um, hardware or mga electronic devices. And we also have this mga reference models, no? So, and also we have this mga layered model. So, when you say layered, meaning motong gini-mention ako nga na sila yung mga different layers of our model na atay duha ka buok nga models, the WSI model and the TCP/IP. So si TCP/IP, as we have mentioned earlier, dala siya upat ka layer, the application, the transport, and the internet and the network access protocol. I mean layer. While compared to the WSI, if you have observed, the three layers of the WSI model is grouped into one sa TCP/IP. So, si application, presentation, and session is grouped sa application sa TCP/IP. And then the transport and the network is lahi sila. Si transport is same, network is internet siya nga layer sa TCP/IP, while the data link and the physical layer is isa lang siya sa network access for the TCP/IP model. So these are the benefits of using a layered model. So it somehow assists on the protocol design, prevent technology capability changes, and it also provides common language to describe, and all especially it fosters competition. Since somehow there is monopoly on the kuano kung isa lang gid ka product ang kuan. So kung naay monopoly, so may tabo o ma-monopolize ang isa ka product somehow, pwede gid nila itaas ang price for that particular product. So mo nang this layered model, no, foster those competition so they can work together. So the OSI reference model, no, so 'di ba natay 7. So the OSI model layer is the kanimo na to gagamiton. So si physical layer, which we have done last meeting, the which includes it describes the means to activate, maintain, and deactivate our physical connection. So meaning mo na itong kakakitaan. While the data link layer na describes methods for exchanging data frames over a common media. And then, see network, it provides services to exchange the individual pieces of data over the network. And same goes with the transport, it segment, transfer, and reassemble those data. And then the session is serve provide services to the presentation layer and to manage data exchange. The presentation is mo na din nitong for the data between the application layer services. So, iyang i-pormahon. While the application line is somehow contains those protocols used to process communication. While sa TCP/IP natay upat lang na application, transport, internet, and the network access. So that if you compare OSI and TCP/ID model comparison, no, um, as what I have mentioned earlier, there are some layers in the OSI model which was considered or grouped into one, then is a TCP/IP. So for the data encapsulation, so segmenting a message is very important as message are more um para dili kay siya inana kabugat or dili kay siya inana para dali ra pud siya i-process. So that's why we have this, we segment messages or we break these messages into smaller units, and then after that our multiplexing is the process of taking multiple streams of segmented data and interleaving them together. So these are the two benefits of having or segmenting your message. It increases speed and also it increases efficiency. So if you have observed kana ganing loading, meaning hinay-hinay na niya gina-download. So iyan ang gina-segment para dili siya bugat pag-load sa ato ang network or pag-travel niya within our network. So we also have this sequencing. So when you say sequencing is naka-arrange na siya. Dili pwede ang nasa last may mag-una. So kung siya ang una gisend, siya gid ang una maabot. So sequencing a message is the process of numbering the segments so that the message may be reassembled at the destination. So TCP is responsible for sequencing the individual segments. So iyan ang gina-label no accordingly or ordering them accordingly. And after that, iya ra po nang i-assemble. Assembling the pieces when they arrive. So, napunta yung mga PDU, no, or the protocol data units. So, since encapsulation, no, is the process where protocols add their information to the data. So, at this stage, no, a PDU has a different name to reflect its new function. So, kani, may tabuan ni is na din siya kaugalingon niya ang different name accordingly. So, the PDUs passing down the stack are as follows. Naatay data stream, natay segment, natay pocket, natay frame, and the bits or bit stream. Meaning, unsahay siya value ana nila tanan dira. So, inana si protocol data unit. And another is the encapsulation, no? Is a top-down process, meaning top down. So the level above does its process and then passes it to down to the next level of the model, and then this process is repeated by the user until it is sent out as a bit stream. So sikan siya sa taas, pabalik na sad hantod mahuman. So more gina siya. So diri pagpasa na niya, so by tabo pagkasunod may mo din siyang bits or may mo siyang bit streams. Then after that, mo nito yung ma-receive ni or that mo padulong nito siya sa application layer. So sa data access, no, we have this, we with both the data link and the network layers are addressing to deliver data from source to destination. So we have the network layer source and destination addresses, and the data link layer source and destination addresses. So, sa atong layer 3 or the logical addresses, now we have this what we call as the source IP address and the destination IP address. So, basically, kung mingon tag source IP address, meaning siya ang sender. So, unsa IP address ato niya? Mao na ang iyan ang i-save or i-apila niya dito sa packet or sa iyang i-create nga layer 3 IP packet. And then, i-apilon po niya ang destination IP address para makabalo siya asa siya padulong. So, after that, the IP address of the receiving device, no? The final destination of the packet. So, mo na siya ang destination. So, example, muping ka sa lahi nga computer or sa lahi nga printer or within the network. So, may tabo is iyan ang i-check kung maubagid ni nga IP address aning padulungan namo. And then the network portion, no, as we have discussed on our previous meeting, no, the network portion and in a network address, no, as what I have mentioned katong discussion on the network address, it's somehow like an address. It's just a same address ato like Kauswagan, Cagayan de Oro. So in ana po siya. There is a network portion which is the first three IP address. For example, kani the first three kani the first three IP address, that is the network portion, and the host portion is kaning last nga group of information or last group of numbers. So these are somehow the identifies the specific device within that particular group. Si network is according to group. Si host portion is yan na ginuwi nga, oh, kanina siya nga PC. Okay? So how do we know if devices have or has is on the same network? So how would you know that? Is that based on their first three nga IP address or first three nga octets. So if have seen like this, you will identify that this computer or these devices are of the same network. So the role of the data link layer addresses now or the same IP network now, it somehow it will just check if they are all of the same network. So mas dali siya pangitaon. And then while devices on a remote network, meaning lahi nga network, so may tabo is kung mag-ping ni siya gani, pag adto niya dito kung iping na niya diri si web server, moagi pa na siya diri ka router 1. Si router 1 dapat makaila pa siya ani sa kang router 2 pod, ay din siya makapadulong kang web server. So if you try to check on their network layer, no, 'di ba? If you try to check on their if you try to check on their network layer, is lahi na sila. Si PC1 is na siya sa 172.168.1. Ana, 'di ba mo na iyang network address. While the web server no, is on a 172.15.1.99. So meaning lahi na sa siya nga network. So that is how you determine if those end devices are of the same network. So the data link addresses now have this two. The MAC addressing for the first segment is the source, then PC1 or the next sends a frame. So meaning the network interface card is mo send na siya og frame or mo send na siya nga oy mauni sila. Then the destination is ana siya first router default gateway interface receives frame. So if you try to check kani, so kani yan nang tan-awon. So the data link addresses includes this one. So si layer 1, kung kaganyan layer 1, inani ang yang destination og source. Si layer 2, I mean si layer 2, si so ang first half is kani, really first ambak. Madto pa na siya sa NIC or sa network interface card. I-check pa na niya, pwede ba ko maka-communicate dere. So madto siya ka router. So pagkahuman, pag sunod niya ambak dayon, madto na siya kang network interface card na po diri sa router, ato na siya dyan sa layer 2. So tanaw niya, destination, mao ba ni ang destination? Then mao din ni ang source. Then yang iya din ang tanawon. Mao ba ni iya ha? Ana. And so on and so forth. So meaning moagi na siya dani. And then if kani sila no, if si PC1 gusto makipag-communicate ka web server, mahitabo dapat na siya default gateway. So si default gateway is like a kanang dalan niya para makagawa siya sa for that particular network. Let's say for example, like kita kung mugawas na sa school, what laing dalan niya na ilan which is the gate. So all of us knows nga ang dalan pagawas sa school is the gate. So wala gid na configure ang atong mind or atong utok nga mogawas sa lahi nga dalan unless na gibuhat nga bag-o nga dalan which is dapat pa pud ipaila-ila na nila. Okay? think that's it. So these are hope you learn all of this, no, information. So we have the reference models, the different the rules, the protocol suites, the standard organizations governing our internet, and the reference models. How do we encapsulate our data, and how do we access our data? And that's it.